Assalamualaikum warahmatullahi wabarakatuh. My name is Mohd Nurazmie bin Muhammad Safiee, and this is my presentation for final year project 2. My title is Comparison of Different Cooling Methods for Milling of Titanium Alloy. This project is wholly supervised by Professor Madya Dr. Liu Pei-jun. We move to the introduction. Firstly, what is milling? Milling is widely used and known as metal removal in the manufacturing industry. This milling process is involving the generation of high cutting force and also temperature. And next is what is titanium alloy? Titanium alloy is a metal commonly used in aerospace industry. This titanium alloy have a characteristic that is extremely hard to machine material. Next, we move to the problem statement. Problem statement first is a lot of heat is generated due to plastic deformation of work material, friction at the tool chip interface, and friction between the clearance face of the tool and workpiece. This formation of heat leads to poor surface finish and higher cutting forces due to the hardness of titanium alloy. And the second is the usage of conventional cutting fluid issue. These cutting fluid issues have three, which is first is biological problem. This biological problem is related to the exposure to cutting fluids may be a cause of skin irritation and of skin cancer. The possibility also exists of a hazard to the lungs from the inhalation of fumes in the machine shops. Next is the manufacturing cost. This cost is related to the fluid purchase, storage, maintenance, and fluid disposal. And finally, the related to the environmental pollution. This environmental pollution issue is regarding the fluid disposal. If the fluid disposal is not done correctly by unresponsible parties, then it spills into open water and causing pollution to the environment. Next, this project objective is to analyze the effect of dry machining, vegetable oil, and nanofluids on the surface roughness and cutting force of titanium alloy. This is the literature review that has been done. From the literature review, we can see that there are many researchers that have done the research for machining of hard steel like this, titanium alloy, alloy spring steel, ICT-04 steel, and also the hardened steel. With the parameters that are viewed, there are different parameters that have been used for the researchers to test the effectiveness of the powder. This is the result of the researchers before. Mostly this result is leads to the lower of cutting force and also lowering the surface roughness. However, the comparison between usage of HBN nanofluid with dry machining or conventional cutting fluid on titanium alloy has not been done yet. Next, we go to the methodology. This methodology, we start with as a primary material. The primary material for the nanofluid that are going to be prepared is hexagonal boron nitrate powder, first with particle size of 20 to 80 micrometer. And next is vegetable oil. Next, we're going to mix this material. But before that, we have to test the suitable surfactant that are going to be used. And from my observation, the suitable surfactant that going to be used is PEN 85. There are several surfactants that have been tested before. Then PEN 85 is the suitable ones. Next is the preparation of the nanofluids. The concentration of nanofluid that are going to be used is 1 weightage %. This is the formula for the calculation for concentration of HBN nanofluids, which mass of solute over mass of solvent times 100. The mass of solute is including the mass of the HBN powder and also add with the mass of surfactant. For my preparation of the nanofluids, I prepare for about 800 gram of vegetable oil, and the HBN powder I use is 4 gram, and the surfactant span 85 I have been used is 4 gram. This nanofluid have been prepared by using the using the ultrasonic homogenizer through the sonication process. This sonication process is done at the 50 amplitudes and 0.5 cycle for 40 minutes. Next, after the preparation of the cutting fluid, we have go to the milling machining with these parameters. The cutting tools that are going to be used is copper carbide, and the feed rate is 0.1 mm per revolution. Cutting speed is 90 meter per minute, and the depth of cut that is going to be used is 5 mm. There are 3 machining conditions that are going to be done. First is dry machining, second is vegetable oil, and third with HBN nanofluids that have been prepared for. During the machining, this is the experimental setup for feeding the coolant, and this is the dynaware setup. This dynaware setup is being done for testing the cutting force. And after the machining process, we will go to the surface roughness test, which using this device, SJ310 device. The measuring spot is that going to be used is with 5 spots, and each spot 3 readings will be taken. And next we will go to the data analysis after have obtained the data. Next with result and discussion. This is the result for surface roughness. The graph shows that the surface roughness is lower by utilizing nanofluid coolants. The presence of HBN nanoparticle dispersed in vegetable oil causes polishing effect and resulting reduction of surface roughness by Abdullah et al. 2013. This polishing effect occurs when the position of HBN nanoparticles in between the cutting material and workpiece. And one author have stated that HBN nanofluid can offer good anti-wear, reduce wear, and improve surface roughness. This is the result for the cutting force. The graph shows that cutting force value is the highest when dry machining was used. Here. And next, the cutting force will be slightly reduced when by using vegetable oil as coolant. And next, the value of cutting force is lowest when using nanofluid as the coolant. The use of vegetable oil. The cutting force can be reduced by lowering the friction between chip tool. Capillary action of nanofluids contributes to the friction reduction and hence reducing cutting force by Sharmin et al. This capillary action refers to the ability of liquid to flow in the narrow space. This narrow space refers to the space between the cutting tools and also the machine material. For conclusion, this nanofluid with HBN nanoparticle could provide better machining performance compared to that dry machining and vegetable oil as coolants. Next is cutting force and surface roughness of titanium alloy can be lowered by using HBN nanofluid as coolants. That my recommendation for this project is future works can be done to investigate what is the optimum concentration of hexagonal boronitrate needed to achieve a good surface finish and low cutting force. This is my reference for this slide. That's all from me. Thank you.